In this video, we are going to see how to define a dynamic selection and how to count the component of this dynamic selection. For that, we are going to use the aspirin dataset that is used in the tutorial 2 on VIAMD's wiki. And you can also find a link in the description for this dataset. In our script, we have parameters that we have evaluated in the video about properties, selection, import-export, and workspace. We are going to start by defining a dynamic selection of water molecules around the aspirin. We are going to place ourselves at the point of the trajectory where the molecule is outside the pocket. We are going to define a new representation, and as a filter, we are going to query the water molecule, so here res name sol, and within 5 angstrom of the res name AIN, which is the aspirin molecule. So we can now change the representation to licorice, and as you can see here, we get a missing hydrogen for this water molecule. Well, this is because this missing hydrogen is not within 5 angstrom of the aspirin molecule. If we want to include all the atoms of a residue as soon as one of the atoms of this residue is within the selection, we can use the keyword residue just before the expression, and like that, the entire water is going to be displayed even if only one atom is within the selection. If we play the dynamic now, we will see the water molecules evaluated for this specific frame diffusing in the box. If you want to evaluate your selection at every frame, you need to check the auto update box. And now we are seeing the water molecule within 5 angstrom of the aspirin evaluated at every frame. We are going to copy this expression and use it in the script editor. We are creating a new property called NB, and we are going to use the count function and paste here my expression for this dynamic selection. We can then evaluate by clicking the button or using the Shift-Enter shortcut, and then we can plot the property by drag and drop NB in the timeline. What's evaluated here is the number of atoms of water molecules around the aspirin. If we want to evaluate the number of residue, we can use the keyword residue as an argument of the count function. After evaluation, we can see by hovering that we are now evaluating the number of residues, and we can clearly see the number of molecules of water around the aspirin increasing as the molecule is moving away from the pocket.